Okay, so hello everyone. I think it's 2 o'clock here in the UK, so it's a good time to get started. Thank you for tuning in, first of all. Welcome, big welcome to the first of our online interactive astronomy talks. My name is Matt. I'm an astronomer here at the University of Cambridge in the UK. Um, Even though a lot of the world is kind of locked down at home at the moment, we're going to be doing our best to provide a range of really exciting and inspiring astronomy talks and activities to keep you occupied and educated and entertained over the coming few weeks. I call this an interactive talk, and it is indeed interactive. There's going to be the opportunity to participate in quizzes and answer questions and ask questions as well. The way we're going to be doing that is through a little thing called Slido. So Slido is an online app that you can join in with talks like this one. So it's very easy to use. The way you do it is to go take some kind of internet device and point it at slido.com, and then you can use the code ASTRO to join in with this talk, and that way you can have the opportunity to ask questions as we go along. So you can either go to slider.com and use the code ASTRO, or you can point your smartphone at the QR code on the right hand side there, and that will basically do exactly the same thing. It's not compulsory, but it's just if you want to have the chance to kind of join in and ask some questions as we go along. We can do that. The instructions for this are also at the bottom of the video and in the video description as well. I should mention that we're doing this in collaboration with the Star Theatre at Morehead State University in the US. So hello to everyone that has joined in from there. So without further ado, let's crack on and talk about some space. So I've called this Our Solar System and Beyond, and what I want to do it as a bit of a journey, right? So what we're going to do is start off with small things that we know about that are very, very near to home, and then as we go along, we're going to get kind of bigger and bigger and further away as we go on a bit of a journey out into the universe. So I think a good place to start our journey is right at the beginning with the place that we live in space. So the place we live in space is, of course, planet Earth. This is our home in the universe, and this is a real photo of planet Earth as seen from space. Earth is a really, really special planet. It's special for loads of reasons. It's special because it's our home in space. Your home in space is always very, very special. It's also very special because it's the only planet we've ever found that we're sure has life on it, right? One of the big things that astronomers are trying to do these days are look for life out there in the universe. But so far, the only planet that we're sure has life on it is our planet Earth here. So it's a very, very special place for lots and lots of reasons. It's also very interesting and a bit strange from an astronomy point of view, as well as being just our home in space, because Earth has a very interesting companion, something that orbits around it once a month, which is very, very unusual. And this is, of course, the moon. And it might seem a bit strange to think of the moon as being unusual, right? It's the moon. We all see the moon. Quite like, it's in the sky half the time. It doesn't seem like a very strange thing at all. Our moon is actually really, really weird. And the reason our moon is so weird is because it is absolutely massive compared to how big it should be. Our moon is actually easily the biggest moon compared to its planet in the solar system. If you think of in terms of diameter, that means like the distance across a ball or something, you could fit about 3 moons across the Earth. And if you think the second biggest moon compared to its planet is Triton, that's a moon of Neptune, and you could fit 20 Tritons across Neptune. So in terms of how big the moon is compared to its planet, our moon is the biggest moon we've ever found. And this was a bit confusing for a long time. Why do we have this big giant moon? And it turns out that our moon formed in a very strange and interesting way. So our moon was actually split off from planet Earth. This was thousands of millions of years ago, back when the solar system was being formed. Something enormous crashed into planet Earth, something probably about as big as Mars, smashed into planet Earth and kind of split it into 2 chunks. And the big bit we call the Earth, and the small bit that got broken off in this violent explosion we call the moon. And so that's how our moon was formed. We know that because when people went to the moon, they took samples of moon rocks and brought them back. And it's just the same as Earth rocks. Earth and the moon is made of very, very similar stuff. So our moon was formed in this very, very violent collision thousands of millions of years ago, which is why we have this very, very special, unique companion. What I want to do is show you now a picture of how far apart the Earth and the Moon actually are, because it can be a bit surprising, right? You often see pictures of the Earth and the Moon, like we see here on the screen. Things in space are often a lot further apart than you might expect. So it's a lot further away than this. It actually looks like this. So this is how far apart the Earth and the Moon are in real life. So we are here on the right-hand side, and then all the way over on the left-hand side, that's the Moon. So this is why it took astronauts about 3 days to get to the Moon, even though they travel in a really, really fast rocket. Space is often a lot bigger than you think. Things in space can be really, really far apart. So while we're talking about the Earth and things pretty close to home, we should also mention things like astronauts. This is the International Space Station. This is a floating space station that's orbiting around the Earth, and this is where astronauts go when they go to space. So I'm sure all you guys have heard of astronauts. They're the people whose job it is to go to space. This is the space station where astronauts go and they conduct experiments and observations and all these kinds of things to teach us more about how space works. Something quite surprising is how high space is. Because I think often if you ask people to guess how high the International Space Station is, people often guess really big numbers like millions and millions of miles. But in fact, the International Space Station is only about 400 kilometers above our heads as it goes over, which is really not very much at all to me. That sounds like it's kind of quite low. And something I find really interesting, this is one of my favorite space facts, is really how low space is. So the border of what we call space starts roughly at about 60 miles above our heads, which it sounds like a long way. You know, if you're going to walk 60 miles, it would take you a very, very long time. But it also means if you could magically drive your car straight up in the air, you'd be in space in like an hour or so. You know, space really isn't very, very far away, right? So outer space isn't some mysterious distant thing. Outer space really is just above our heads. Okay, I want to do a quick quiz now. The people listening from the UK might have a slight advantage, so apologies to international international listeners, but we can all have a go at this as well. What I'm interested in finding out is if you know who is the name of the first British astronauts, the first astronaut from the UK. So for those of you that are playing along at home, you can choose your answer now. I'll give you about 30 seconds. To have a think. Oh, this is exciting! I can see the votes coming in. There's lots of question and answers coming in already as well, which is very exciting. Okay, the votes are coming in. Let's see the results, shall we? Who is the first British astronaut? So Tim Peake and Helen Sharman tied for the top two. So some points for those definitely. So Tim Peake and Helen Sharman are the two British astronauts. Neil Armstrong and Buzz Aldrin were the part of the team that went to the moon for the first time. The answer is actually Helen Sharman. It's not Tim Peake. Tim Peake is probably the most famous British astronaut, but Helen Sharman was the first astronaut from the UK. So 36% of you, about a third of you, got that one right. So this is Helen Sharman. She should be more famous than she is, I think. Like I said, Tim Peake, very great at very great at what he does. He's very, very well known. But I think Helen Sharman should be more well known. She was our first astronaut and is a very, very important person. Okay, let's get a bit bigger. So we're talking about quite small things here, aren't we? We're kind of talking about the Earth and astronauts and things very, very close to home. If we get a bit bigger and take a step back, we can have a look at this. And so this is a picture of our solar system. Often when I ask people what this is a picture of, the reaction is it's the sun or something, because the sun completely dominates this picture. The sun is easily the biggest thing in this picture. And what this is, so this is a special picture of the solar system where we've shown you the sizes of everything in comparison to each other. So just like the Earth and the Moon are actually really, really far apart, all the planets in the solar system are actually really, really far apart as well. And it's actually quite difficult to show what the whole solar system looks like on one really, really big picture because the planets are so far apart. And so for this picture, we've kind of squished up the planets so they can fit onto one screen. And so you can really see how much bigger the sun is than all the planets. But if we zoom into the planets, so the sun is the star that's at the center of our solar system, and stars and planets are very different, right? Stars are big and burn, and they like send out heat and light. Planets are much, much smaller and much, much cooler, and it's planets that orbit round the sun. So this is our solar system, and the order of the planets, which a lot of you will know, I imagine, goes Mercury, Venus, Earth, Mars, and those are the four small rocky planets, then Jupiter, then Saturn, then Uranus, then Neptune. So these are the 8 planets in our solar system, and there are lots of nice mnemonics, nice little kind of rhymes and memory games you can remember these planets with. So now we have 8 planets in our solar system, but not very long ago there used to be 9 planets in the solar system. And the reason is that Pluto, poor old Pluto, used to be counted as a planet, but in 2006 it got demoted to be a dwarf planet. So Pluto hasn't changed. Pluto's the same as it always has been, but we now call Pluto a dwarf planet instead of one of the main planets in the solar system. Not a lot of people know why this is. I think often if you ask people why is Pluto a dwarf planet, people think it's because it's too small or too far away. Actually, none of that's true. The real reason we call Pluto a dwarf planet is because of where Pluto is in the solar system. So Pluto lives way out past Neptune on the right-hand side of this picture in this really messy part of the solar system called the Kuiper Belt. And there's loads and loads of rocks and space junk all out in the Kuiper Belt. It's like a second asteroid belt in the outskirts of the solar system. And Pluto was the first thing that we found in the Kuiper Belt, but now we know there are loads of things just like Pluto. And if we were going to call Pluto a planet, then to be fair, we'd have to call everything that's Pluto-sized out there a planet, and we'd end up with like 10,000 planets in the solar system, or even more, which would be ridiculous. And, we can remember 8 planets. No one's going to remember 10,000 planets in our solar system. And so to make life easier, we say that everything out there counts as a dwarf planet, then these are the 8 main planets in our solar system. I just want to show you some pictures of the planets now, because the planets are absolutely beautiful and fascinating. So this is a picture of Venus, the second planet in the solar system and the hottest planet in the solar system. You can see it looks all kind of yellow and smoggy, and that's because Venus is one of the most horrible places to live in the solar system that you will ever come across. The surface of Venus is very, very acidic. There are clouds of sulfuric acid, and the whole thing is incredibly dense and pressurized. So you know how if you swim down deep in a swimming pool, down under a diving pit, your ears start hurting because the pressure's building up? Imagine that, but like times a million. So the pressure on the surface of Venus is nearly 100 times greater than the pressure on the surface of the Earth. It's the equivalent to being a kilometre down underwater. Even robots don't last very long on the surface of Venus. And so these, in the very, very bottom of these photos, you can see these little robots that were sent to Venus to take photos. And even robots don't last very long because the atmosphere is just so horrible. So Venus, even though it's very, very close to us in the solar system, it's still quite mysterious. So this is Mars. Mars is a very, very cool planet. And luckily for us, Mars is, although not quite as nice as Earth to live on, a lot nicer than Venus to live on. Because one of the things that people are hoping to do in the near future is send humans to Mars, and maybe in the not too distant future, send humans to Mars to actually live there for some length of time. Mars used to look a lot more like Earth does nowadays. So even though Mars nowadays is this horrible, dry, dusty desert planet, in the past, Mars used to have water on it. It used to have lakes and rivers, just like Earth does. And one of the big mysteries about Mars that we're trying to understand is what happened? Why did it go from this place with lovely rivers and lakes and turn into this dusty, dry desert planet? Why did Mars lose all its water? The way we are finding out answers to these questions is to send these explorers to Mars. So this is a picture of Curiosity. This is what's called a Mars rover. It's a robot that we put on Mars to have a look at the surface. You can see it's zapping rocks with its laser to learn what they're made of. It always makes me feel like I'm living in the future, that there are robots on Mars right now. Mars is populated entirely by robots. Isn't that an amazing fact? And so we're learning more about Mars because of these robots that we put on the surface. So I showed you a picture of the surface of Venus before. This is a picture of the surface of Mars. I love this photo so much because it really looks like this is exactly what it would look like if you were standing on Mars. It makes it seem like such a real place, but this is the real view from another planet. And right at the bottom, you can see the bits from the Mars rover. You can see the solar panels, and you can just see the Mars desert landscape just stretching off into the distance. So like we said, we're trying to send people to Mars, so maybe in 20 or 30 years' time, hopefully people will go to Mars. And when they do, the first person to go to Mars that steps off the spaceship is going to see this. This is what it's actually going to look like when you stand on the surface of Mars. So that's something very, very exciting, I think, that everyone in science is looking forward to a lot. So if we journey now to the outer planets, this is Jupiter. Jupiter is my favourite planet. So this is what Jupiter looks like when you see it from a telescope from Earth. But we've actually been to Jupiter. We've been to the outer planets. We haven't sent people, but we have sent spacecraft with cameras to the outer planets to take photos of them. And this is what Jupiter looks like when you see it from really, really up close. So this was a photo taken by a probe called Voyager that did a close flyby of Jupiter. And this is a photo from really, really up close Jupiter. I love this photo. I always think it looks like an oil painting or maybe milk being stirred into coffee or something. It doesn't quite look real, but it is completely real. And what we're seeing here are the clouds on the very, very surface of Jupiter's atmosphere. The big kind of red blobby thing on the right-hand side has the very imaginative name, the Great Red Spot. Astronomers are really good at naming things. And what this is a hurricane. It's a giant hurricane that's been blowing on Jupiter for hundreds and hundreds of years. And even though it is just a hurricane, it's a lot bigger than hurricanes that we have on Earth. So I'm going to show you a photo now of how big our planet Earth would be on this picture. You ready? It's about that big. So this is why Jupiter's my favourite planet. It has a hurricane that's bigger than the entire world on it. It's an absolutely amazing place. Jupiter is so big, you could fit about 1,400 Earths inside it. So moving on to more of the outer planets, this is the planet Saturn. Again, this is a real photo. It doesn't look quite real, does it? This is, again, taken by a spaceship called Cassini. And we've brightened up the photo so you can see all of the rings around Saturn. This photo of Saturn is really, really nice because you might not be able to tell from here, but Earth is actually in this picture. And if we do a zoom in here, we can see Earth just poking out from between the rings. So that's Earth right there. And if you squint really hard at your screen, you might even be able to see a tiny blob to the bottom left of the dot, which is Earth's moon. So this is again, it gives you an idea of just how ridiculously big space is. You can just see this tiny dot, that's Earth, way, way, way beyond Saturn. Saturn's rings are really, really interesting. Saturn's rings are... I'm going to go back to Saturn. Saturn's rings were formed a lot later than Saturn itself. So for most of Saturn's life, it didn't have rings. It was just sitting there as a slightly boring yellow planet. Saturn's rings were formed at roughly the same time that the dinosaurs died out, so maybe around 100 million years ago. And they were formed when one of Saturn's moons just got into the wrong place at the wrong time. So Saturn has loads of moons. It has about 82 moons at the moment. And in the past, one of Saturn's moons, like I said, was in the wrong place at the wrong time and got squished to bits by Saturn's really extreme gravity. And the rings are what's left over from this moon that got destroyed. The rings are also disappearing. The rings are raining down onto Saturn. So if you got on a time machine and went forward another maybe 100 million years, which is quite a long time, Saturn wouldn't have rings anymore. So I feel quite lucky that we're living at exactly the right point in history that we can see Saturn's beautiful rings. This is the planet Uranus. Uranus, there's not much to look at with Uranus. It's a very, very kind of smooth, blobby planet, but it's a very important planet because it was the first one that was discovered in modern times. So this was found by a man called William Herschel, who used his telescope to see it. Because all the planets I've been talking about so far, Mercury and Venus and Mars and Jupiter and Saturn, you can just see with your eyes. If you know where to look, you can just see them in the sky and they look a bit like stars. But Uranus and Neptune and Pluto needed telescopes to discover. So we went thousands of years without without knowing that this planet existed until it was discovered a couple of hundred years ago. So this is Uranus, this is Neptune, the windiest place in the solar system. I'm just going to skim fast past these planets, but I do want to show you Pluto. So I absolutely love this photo of Pluto. So Pluto is very, very far away. It's this dwarf planet that's right on the edge of our solar system, and it's so far away that to even recently, with our best telescopes, Pluto was just a tiny little dot. But we were able to get this amazingly beautiful photo by actually going to Pluto. So we built a spacecraft called New Horizons, and it had the mission to go out into the solar system and spent years flying through space and did a flyby of Pluto and snapped this photo as it went past. So we are some of the first people in history to know what Pluto looks like. Okay, I want to show you this video now because I showed you a photo of the whole solar system before, and if you remember, it had the sun on the left-hand side and all the planets out in a line. That's often how you see the solar system in photos and books and stuff, but it's not really the best picture of the solar system to have in your head when you're thinking of what the solar system really looks like. So when you think of what the solar system really looks like, I want you to imagine something that looks a bit more like this. So the sun is at the center of the solar system, and it's all of the planets are orbiting around the sun. So the word orbit just means being pulled around by the sun's gravity in space. So the colored lines aren't really there, right? The colored lines are just showing you where the planets are moving, and it's the sun's gravity that holds the whole solar system together. Okay, it's quiz time again. So I showed you this photo before of the Earth and the Moon, and remember I was saying just how far apart the Earth and the Moon really are. I want you now to think about if you could fit planets in between the Earth and the Moon. So we're going to start off with Jupiter, and I want you to think about whether it would be possible to fit Jupiter in between the gap in the Earth and the Moon. Remember, Jupiter is the biggest planet in the solar system. It's so big you could fit about 1,400 Earths inside it, and it's got a storm that's bigger than the world. So could you fit Jupiter in that gap between the Earth and the Moon? Vote now, and I'll give you a little bit of time to vote. Just while the voting is going on, I'm going to have a look at some of the questions that are being submitted. There are lots of really, really fantastic questions coming in, so keep them coming. Okay, let's see the results. About 100 people have voted. Let's see the results. So 2/3 of people saying no, Jupiter is too big to fit between the Earth and the Moon, and about 1/3 of people saying yes, you could fit Jupiter between the Earth and the Moon. Very interesting. Okay, this makes me very happy because I get to surprise you all with my favourite space fact. Are you ready? So the gap between the Earth and the Moon is in fact big enough to fit, drumroll, not just Jupiter, but every planet in our solar system. This is literally one of my favourite space facts. I find it completely mind-blowing. You could fit every single planet in our solar system in the gap between the Earth and the Moon. That's how big things that's how far away things in space are. So I really want you to remember, next time you go out and next time you look at the Moon, remember that you're seeing something that's so far away. You're seeing something that you could fit every single planet between you and the thing you're looking at. Space really is very, very big. Okay, quiz time again. What is the nearest star to Earth? And this one's not multiple choice. I think of this one you have to type in your answer. So there are lots of stars in the sky that we can see. I want you to have a think about what the nearest star to our planet Earth is. And again, I'm going to give you some time to have a think of your answer. Now, I'm going to look through some of your questions while we're doing that. Keep these questions coming. They are really, really fantastic questions coming in. About 60 votes so far. I'll just give you a little bit more time. There are really nice questions coming in that I've made live. I think you can vote on questions. So if you see a question you like, I think you can click on it to send it to the top. Okay, with about 100 votes come in, let's see what the answers are. Wonderful. Okay, this makes me very happy. So yes, the Sun and the Sun, by far the most popular answer, with Alpha Centauri, the North Star, Proxima Centauri, in slightly second choice. So the answer is absolutely the Sun. Apart from the Sun, the answer is Proxima Centauri. That's the second closest star. But the answer is very much the Sun. The reason I was asking the question, because it feels like a bit of a trick question, doesn't it? We think of the sun and the stars as being really, really different. You know, the stars are the little cold, twinkly things at night, and the sun is a big, hot, burning thing we see during the day. But the only reason the sun looks different to us, and the only reason we think the sun is, you know, a different thing, is that we're really, really close to the sun, and we're really, really far away from the stars. The sun is just a totally normal star that we're really, really close to. If you could fly in a spaceship and get further and further away from the sun, it would get smaller and smaller and colder, and until eventually it just looked like any other star. And the same is true of all the stars in the sky as well. So if you next time you go out at night, you can just pick a star, and you can know that what the thing you're looking at is a sun, very much like our sun. And something that astronomers are working on at the moment, this is one of the most exciting things in astronomy at the moment, is learning about all the planets around these other stars. So we've been talking about our solar system quite a lot, but we're not the only solar system, right? Our sun isn't special for having planets around it. All of these stars in the sky have their own planet, or a lot of these stars in the sky have planets around them as well. And so one of the most exciting things that astronomers are doing nowadays is finding and learning all about these other solar systems. And that leads on to doing things like looking for signs of life and learning how planets formed. Okay, I want to show you a quick video now, because there are all different kinds of stars. So there are, just like there are big planets like Jupiter, and there are small planets like Venus and Mercury, there are also big stars and small stars. And even though the sun is really, really enormous, there are some stars out there that can make our sun look pretty puny. So I'm going to play you this video. Credit goes to, there's a YouTube channel called Morn1415 for this wonderful video. So what we're going to be doing is looking at the sizes of some different things in space. And we're starting with small things. So these are the little rocky planets in the solar system. And then if we want to see the gas giant planets, we really have to step back, right? This is Neptune. This is Saturn without the rings, just so we could fit it in. And this is Jupiter. But then remember how much bigger the sun is than the planets, right? The sun is just huge compared to the planets. But even so, the sun really isn't very big to some stars that are out there. So that was Sirius, the brightest star in the sky. And these are now giant stars. So these are stars that are close to the end of their lives, and they've swelled up really big, and they're just about to explode in something called a supernova. So these are called giant stars and supergiant stars. But there's an even bigger kind of star still called hypergiant stars. And these even make giant stars look pretty tiny. And then coming up now, this is one of the biggest stars that we know about. It's called VY Canis Majoris. It's one of the biggest stars out there. And we can do a zoom in now to see how big our entire planet Earth would be compared to this star. So if we go zoom, 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 zoom. So that tiny dot is how big our entire planet Earth would be compared to that enormous star. And things like this always completely blow my mind. It just makes you realize how vast space is. There are some really, really amazingly big things out there in space. So let's get a bit bigger. We've been talking about things that were getting bigger so far, right? So we started off with the Earth and our solar system, and now we're talking about other solar systems and other stars. We can take a step back again and ask, well, where do all these stars live? So this is a picture taken from Earth, and the big stripe of light you can see across the sky is something called a galaxy. That's our Milky Way galaxy, and a galaxy is the name for a big collection of stars. So this is what our galaxy looks like if you're inside it. If you could fly outside of our galaxy, it would look like this. So this is a picture of our Milky Way galaxy. It's not a real picture, it's a drawing of what we think the galaxy looks like. And so this is our home galaxy in space, and our solar system is about here, more or less. So galaxies are really, really big. In fact, they're so big. If you talk about their sizes in terms of miles or kilometers, the numbers kind of become so big your head falls off and they stop making any sense. And so when we measure the size of really big things like galaxies, we have to use special units called light years. A light year is a way of measuring a distance, and it's how fast you would travel. It's how far you would go if you could travel at the speed of light for a whole year. So the speed of light is the fastest thing there is. It can get to the moon in 1 second, and it can get to the sun in about 8 minutes. Even though the sun is 100 million miles away, you can travel that distance in 8 minutes at the speed of light. Even still, it would take about 100,000 years to travel from one side of our galaxy to the other. So even at the speed of light, the fastest speed that exists, it takes 100,000 years to go across our galaxy. Galaxies are really, really big things. And it's a big cloud of stars. So all this lovely swirly light you can see, it's all just stars. There are somewhere between 200,000 million and 400,000 million stars in our Milky Way, which, if you're anything like me, those numbers are just so big that you can't even imagine it. There are many, many more stars in our Milky Way than there are even people in the whole world. One of my favourite ways of describing how big galaxies are would be, if you imagine you could shrink everything down. Imagine you had a magic shrinking machine and you could shrink everything down until the solar system was the size of a small coin. So like a quarter if you're American, or a 10p if you're in the UK. And so imagine holding that coin and imagine that the sun is in the middle and the orbit of Neptune is around the edge. If that's how big the solar system, on the same scale, our Milky Way galaxy is about the size of all of America, which is completely amazing to me. So when I say we are here, so that arrow pointing out where our solar system is, that's like pointing to a tiny coin lying in a field somewhere compared to all of America. So even though our solar system is big, our galaxy is much, much bigger. Galaxies are the most enormous and amazing things. I absolutely love galaxies. So this is not a real photo of a galaxy, right? Because it's our own galaxy, we can't get outside to see what it looks like. So we have to do a drawing of what we think it looks like based on the best kind of evidence from telescopes. But what we can also do is look at other galaxies, because we're not the only galaxy in the universe. There are loads of galaxies out there. And so this is a video of the Andromeda Galaxy, which is our nearest neighbour galaxy. So we're starting off with an all-sky image. That really huge galaxy you could see was our Milky Way, and it's so big because we're inside it. And we're zooming in now to the Andromeda Galaxy. So the Andromeda Galaxy, you can think of it like the Milky Way's twin galaxy, basically. It's a little bit bigger than the Milky Way, but it's quite a good idea of what it would look like if we could see our own Milky Way from the outside. And this is a video taken by the Hubble Space Telescope, and we can zoom in now, just to give you an idea of how many stars are in a galaxy like this, because I said this number 200,000 million stars, which for me is just too big, right? These numbers are so big they stop making sense. But what you can do, you can take this amazing photo from the Hubble Space Telescope and zoom in and zoom in and zoom in, and then you can see all of these stars in the Andromeda Galaxy. And so those big dots were the biggest stars, but even those little grains that look like kind of grains of sugar on a table were all stars as well. There are so many stars in the galaxy, it's almost hard to imagine. And this is why a lot of people think, there could well be life out there, because every dot you could see there was a sun with its own solar system as well. And so this is why we're trying so hard to find signs of life in space, just because there are so many places out there that life could exist. So if we get bigger again, so we're almost at the end now, so we can get bigger again and step back and see our little corner of the universe. This is our Milky Way galaxy on the left, and this is Andromeda that we've been looking at on the right. And we can really just keep on stepping back and stepping back and stepping back and seeing all of these galaxies out there. So how many galaxies are there? In the whole universe, how many galaxies are there? And the answer is we don't really know for sure. We can't see everywhere in the universe to count the galaxies. What I want to do, and this is going to be the last thing I show you before we do some questions, is give you an idea of the best experiment we've done to try and have a guess at how many galaxies are out there. So I mentioned this thing called the Hubble Space Telescope before, and that's one of the best telescopes in the world that we actually put in space, and it orbits around the Earth, taking photos of things in space. So when the Hubble Space Telescope was brand new, what we wanted to do was to take a photo of a patch of sky, and we chose this very, very tiny patch of sky that's about that big compared to the full moon. Another way of saying it is that it's about a quarter the size of your pinky fingernail if you hold your pinky fingernail at arm's length against the sky. So if you do that now, if you hold your pinky fingernail at arm's length kind of against the roof, and imagine how much sky is covered by about a quarter of your nail. It's a tiny, tiny patch of sky. And we took this tiny patch of sky and we observed it for weeks and weeks and weeks with this brand new fancy space telescope to try and get a photo of all the galaxies inside it. And this is what we saw. This is, I think, my favorite photograph of all time. It's called the Hubble Deep Field, and this is the photo of what that sky looked like in that tiny, tiny, tiny patch. The amazing thing to me about this picture is that everything in this picture is a galaxy. Right, it looks like a starry night sky, but in fact every dot is a galaxy, and you can see some things that are quite nearby galaxies, but even the tiny, teeny little specks that you can barely see are actually galaxies just right across the other side of the universe. So there are about 10,000 galaxies in this picture, and which means that in the whole universe there are almost certainly more galaxies than there are even stars in our Milky Way. Which means there are more stars and more solar systems in our universe than there are grains of sand on every beach in the world. And so this is why astronomy is amazing to me, and this is why you should all grow up and become scientists and become astronomers to study this. It's because there is so much of this big, beautiful universe out there, and there's so much more to learn about it. So I think we've reached the end. We've reached the biggest thing of all, talking about the entire universe. I think what I want to do now is go over and answer some of your questions, because I can see you've been submitting questions as we go along. These are all really, really nice questions. So the first one from George M. If the moon broke off from the Earth, why are they such regular shapes? This is a really, really good question. The answer is that the collision that broke the moon off from the Earth would be a lot more messy. It wasn't just a neat little nice collision where a Mars-sized thing came down and broke off a bit of the Earth. It would have been an absolute smash of kind of lava spread through space. And so if you came back like a year after the collision, you probably wouldn't have been able to recognize the moon at all. It would have just looked like a mess. But then over thousands and tens of thousands of years, gravity kind of reformed the mess, basically. So all of the kind of smash of lava that got broken off, gravity reformed them into ball shapes. So the moon didn't originate, the moon didn't first form as a nice ball shape. It's the action of gravity that turns it into this nice ball shape, and it would have taken a very, very long time. That's a really, really good question. Thank you. Mia and Ava say, do you think there are any other planets that have life on them? I would love to know the answer to this question for sure. The answer is no one does really know. My own personal feeling is that yes, I think there has to be life out there somewhere. We know this because we live in a universe that's full of planets. On average, we think every star has like roughly a planet. And so we live in a universe that is full of hundreds of thousands of millions of planets to live on. And we also know that the ingredients for life are everywhere throughout the universe. So we live in a universe where water is really, really common. We live in a universe where carbon, that's the stuff we're made of, is really common. Even stuff like amino acids, these are like the ingredients in our bodies that kind of make our proteins. We find amino acids in space. So all of the ingredients for life are everywhere out there in space. And so I think there has to be life there somewhere. It's a very, very big universe. But I don't think we've found it yet, right? I'm not saying we believe in, I'm not saying I think little green people have visited and are flying around with UFOs. I don't think that's true. But as for life out there in the universe, my bet would be yes, even though right now we don't know for sure. Noah, age 7, is asking the really big questions. Why did the Big Bang happen? This is another question that I would love to know the answer to. We understand a lot about the Big Bang. So since the 1960s, when we discovered that the Big Bang theory was true, because we could hear the echo from the Big Bang, and we can tell that the Big Bang happened because we live in a universe that's getting bigger and bigger and bigger over time. So we know a lot about what happened to the Big Bang and how it worked. But as for why did the Big Bang happen, like what caused the Big Bang, I think right now we have to say we don't know. But the nice thing about science is that sometimes the best answer you can give is, I don't know, and then you can go and actually find the answer. So even though we don't know the answer right now, a lot of scientists all over the world are trying to study the Big Bang more to learn the answer. So right now the answer is we don't know, but in the future it might be something that we can go and find the answer. Maybe you'll find the answer. Maybe you can go and grow up and become a scientist and help us learn why. That's another question that I would love to know the answer to. Okay, Jacob says, is it true that every time the moon rotates around the Earth, the moon gets further away? That is actually true. So the moon is actually getting further and further away all the time. So the moon gets further away from the Earth by about a centimetre per year. Which doesn't sound very much, but over hundreds of thousands of years and over millions of years, this really, really adds up. Another interesting thing about this is that as the moon gets further and further away, it's going to appear smaller to us in the sky, and so in the future, like solar eclipses won't happen, right? Solar eclipses only happen because the moon exactly covers the sun. In the future, when the moon is further away, it's going to be smaller than the sun. So we are again quite lucky to be living at exactly the right time in history where we can see these amazing solar eclipses. How many Earths can fit into the sun? That's a really good question. The answer is about 1.4 million, which again is such a ridiculous number. It's hard to even imagine. But yeah, you could fit somewhere around 1.5 million Earths into the sun. How are stars made? That's a really good question. So stars are made from gas, first of all, and there are floating clouds of gas in space that we can see with our telescopes. The start of stars being made is when these gas clouds start getting squished down by gravity, right? So you start off with a cloud that's sitting there in space, and then gravity starts squishing it smaller and smaller and smaller. Now, this is going to sound like a slightly strange thing to say, but if you've ever got a puncture on your bike and you've had to pump up your bike's tyre, you might have noticed that the end of the pump gets quite hot. And the reason for that is that it's a law of nature that when you squish gas up really small, it gets hot. And that's what's happening when you're pumping air into your bike tyre. You're taking all the air in the atmosphere and squishing it into your tyre, and that makes it heat up. And the same thing happens to the cloud of gas in space that's being squished up by gravity. So you get a cloud of gas in space, gravity squishes it smaller, and as it gets smaller and smaller and smaller because gravity's squashing it down, it gets hotter and hotter and hotter. And eventually it starts a special burning process and becomes a star. That's a really good question, but yeah, the basic answer is you have a cloud of gas in space and gravity squishes it down and it becomes a star. What's the biggest planet? The biggest planet in our solar system is Jupiter. The biggest planet outside of our solar system, I actually don't know the answer to. That's something you could look up. There are about 4,000 planets around other stars that we know of right now, and we're finding more all the time. So that one I have to admit I don't know the answer to, but if you could go and Google it after this talk and have a look. What's the mass of a black hole? That's a really good question from Leo, aged 8. So there are actually two types of black hole. So there's you get black holes that are formed when very big stars die. So if you remember that video I showed you of all those really, really ginormous stars at the end, when one of those stars dies, at the end of its life, it's going to become a black hole. And those black holes weigh roughly about the same as a star. Maybe 10 times as much as the sun or something like that. So these are the kind of small black holes. But there are also much, much bigger black holes, and these are called, unsurprisingly, supermassive black holes. And these live in the centers of galaxies. So these are really, really special black holes, and there's only one per galaxy, and they're all right in the middle. And they can weigh millions and millions of times as much as a star. The one in the center of our Milky Way is called Sagittarius A star, and it weighs about 4 million times as much as the sun. So the answer, what's the mass of a black hole, depends what kind of black hole you're talking about. If it's what's called a stellar black hole, then it weighs roughly-ish about as much as a star, maybe 10 times as much as the sun or so. Or if you're talking about a special supermassive black hole, it can weigh millions of times as much as a star. Good question. Oscar and Harrison ask, is the sun made of lava? Actually, no. So the sun is actually made of something that's hotter than lava. So lava is melted rock. But the sun is actually made from gas. It's made from a gas called hydrogen mostly. The reason it's so hot is because there's a special explosion burning process going on right in the middle of the sun. That's a bit like a nuclear bomb. And it's much, much hotter than lava. The temperature at the center of the sun is about 15 million degrees. So yeah, not quite lava. It's actually made of very, very, very hot burning gas. How big is Saturn without its rings? That's a really good question. That's another question I don't actually know the answer to. That would be one to go and look up afterwards. Yeah, I'm not going to guess in case I get it wrong. I don't know the answer off the top of my head. Good question though. Why does the solar system exist? From Noah. Another really, really nice question. So the solar system formed at the same time as the sun. I was talking earlier about how stars form, right? You start off with a cloud of gas in space, and then gravity squishes it down and forms a star. Well, at the same time, while a star is forming, the bits of the leftover gas that didn't go into the star, gravity turns them into planets. And so you get planets forming at the same time as stars, right? So the sun and the planets in the solar system were all formed at the same time from the same cloud of gas. And so solar systems exist for the same reason that stars exist, which is they form from clouds of gas in space. This one I double pressed, I beg your pardon, but what RPM do neutron stars spin at? So how many revolutions per second, how many revolutions per minute do neutron stars do? It depends on the neutron star. Some of them can be very, very fast indeed. So neutron stars, some neutron stars are called pulsars, and these are kind of very, very strong magnetic neutron stars that kind of shine out really brightly in the night sky in radio waves. Pulsars can spin at hundreds of times per second. So many, lots of revolutions per minute, hundreds of times per second, the fastest ones. Why is the moon a different color from the moon? I assume this means why is the moon a different color from the Earth, from Liberty? That's also a really good question, because I said earlier that the moon and the Earth are made of the same thing, right? Because the moon broke off from the Earth. So why are they a different color? Well, if you think about what the colors are, right, the moon is kind of grey, and the Earth is blue and green and white sometimes because of the clouds. The reason the Earth is blue and green and white is because of water, which is blue, and plants, which are green, and clouds, which are white. And all of those things, the water and the clouds and the plants, only exist because of the atmosphere of the Earth. So underneath the water and underneath the plants, the Earth is kind of a ball of rock, just the same as the moon. But because the Earth is big enough to have an atmosphere, that means it can keep life on it, and so plants can survive and water can survive without disappearing off into space. And so because the Earth is bigger than the moon, it can hold on to an atmosphere, which means it gets all these kind of exciting colours. If the Earth was too small, we wouldn't have an atmosphere and we would be grey like the moon. Good question. Why is the moon made from rocks? So the moon is made from rocks, just like the Earth is made from rocks. So there's all kinds of stuff in space, and that were in the kind of the cloud that formed the solar system, and all the little bits get squished together by gravity and turns into little rocks, and that turns into the moon. So the moon's made from rocks for the same reason that the Earth is made from rocks. Good question, Patrick. Are there more planets like the Earth? This is a really, really good question, and this is one of the most important and exciting things that's happening in astronomy at the moment, is looking for other Earth-like planets. We don't know for sure, but the answer is almost certainly yes, because we found planets orbiting other stars with all kinds of different properties. We found kind of big ones and small ones and hot ones and cold ones. And what we're trying to do right now is find lots of planets which are similar to Earth. We call them Earth-like planets. They are definitely out there. We are actually launching a special camera into space called Plato in the next few years. And one of Plato's big jobs is going to be finding lots and lots and lots of planets just like the Earth. And so the answer is definitely yes, there are more planets like Earth out there. and in the near future we're going to be finding lots and lots of them, which is also very exciting because once we find Earth-like planets, we can start looking at them more closely and studying their atmospheres, and even asking really, really big, exciting questions like, maybe they have living things on them. How far away does the ISS orbit from Earth? I think we covered that one in the talk, didn't we? It's about 400 kilometers straight up, which really doesn't sound very far to me at all. Sorry, I'm getting behind with these things. William Mayer wants to know, does space ever end? This is another one that I would absolutely love to know the answer to. And Anonymous asks exactly the same thing. Is there an end to space? The answer again has to be we don't really know, and we don't really know this one for quite an interesting reason. So there's something called a horizon to space. So it's a bit like the horizon on Earth. It's like a thing that you just can't see past, no matter how hard you look, because there's no way to see. There's a horizon in space called the cosmic horizon. It's a lot further away than the horizon is on Earth. It's about 46,500 million light years away. But there's a horizon there in space because light just hasn't had time to reach us there since the Big Bang. So the Big Bang happened about 13,000 million years ago, and anything outside the horizon, the light just hasn't had time to reach us. And so space might have an end, or it might keep going forever. But yeah, again, we don't know, and I would love to know the answer to that. How big are stars? Anonymous asks. Some of them can be very, very big. So if you remember that video I showed earlier, and again, this talk is going to be available to watch online if you didn't catch it at the time. Some stars can be very, very big indeed. So the sun is big enough to fit about 1.5 million Earths inside it. But even the sun is quite small compared to some of those biggest stars out there. The biggest stars of all are big enough that if you could replace our sun in the solar system with those really, really big stars, so VY Canis Majoris is one, or UY Scuti is even slightly bigger. If you could replace our sun with one of those stars, they would reach out to about the orbit of Jupiter. So some stars out there can be very, very, very big indeed. And last question, Alex and Joe ask, how old is the solar system? Another really great question. It's about 4.5 billion years old. I'll explain what that means, because we use these big numbers quite a lot, right? We use numbers like billion and million quite freely. A billion is bigger than a million, and it's 1,000 times bigger than a million. In fact, one way to understand how much bigger a billion is compared to a million is imagine you're going to clap once per second and count your claps. To get to 1 million claps would take you about 3 weeks, right? So you'd have to just stand there for 3 weeks straight, no eating dinner, no going to sleep, stand there for 3 weeks straight, clapping once per second, and you would clap 1 million times. To clap 1 billion times, to reach 1 billion claps, would take about 35 years. So that's how much bigger a billion is than a million. It's a lot bigger. So when I say the solar system is about 4.5 billion years old, that's 4,500 million years old. It's very, very old indeed. And I think can't see any more questions coming in. Oh, there are more questions coming in. I'll do some before the end. Gracie7 says, why doesn't the moon have life on it, just like the Earth does? This gets back to what I was saying before about the atmosphere. So the only reason the Earth has life on it is because there's an atmosphere. So the atmosphere is the air around us that we're breathing. If you take a big breath, what you're breathing in is air from our atmosphere, and it's the atmosphere on Earth that lets life exist. The moon is too small and doesn't have an atmosphere, and so it doesn't have any life on it. So that's why, even though the Earth and the moon are made of the same stuff, that's why the moon doesn't have any life, but the Earth does. It's all about the atmosphere. Okay. I think so. It's coming up to 3 o'clock. I think this is probably quite a good time to finish. Thank you all so much for listening. I hope you have enjoyed this. Like I said, this is the first of many talks. We're going to be putting on all kinds of exciting things over the next few weeks. They're going to be talks for all ages, including children and including adults.